Welcome to the Explainer. So today we're tackling a pretty huge topic, a kind of geological time bomb that's ticking away quietly in the Himalayas. We're going to get into the science of this immense tectonic pressure and really what it could all mean for one of the most populated places on Earth, a region that includes the megacity of Delhi.
For the scientists who study this stuff, the incredible forces at play where the Indian tectonic plate is just slamming into Asia, this isn't some wild guess. The threat of a massive earthquake, it's not speculation. It's a certainty. It's a story that's literally written into the rocks of the mountains themselves.
And yeah, this map, this really gets to the heart of the problem, doesn't it? Those shaded areas? Those are the rupture zones from massive, ancient earthquakes. Now look at the grid laid over top of it. That's the population density of northern India today. You can see it right there, a direct collision course. We're talking about a seriously active seismic zone right underneath a region that's home to more than 260 million people. It's a staggering thought.
All right, so to really get a handle on what could happen in the future, scientists have had to become detectives, digging deep into the past. It's this incredible field of work all about uncovering earthquakes that happened way before we had any instruments to measure them.
Okay, let's get into what this is actually called. The science is known as paleoseismology. And honestly, the best way to think about it is like geological forensics. I mean, scientists literally dig these huge trenches right across a fault line so they can read the history of old earthquakes, a history that's preserved in all those layers of soil and rock. So how does this detective work actually work? Well, geologists are searching for clues. They're looking for things like abrupt cuts in the soil layers or folds where the ground has been violently pushed up. And then they find these little bits of organic material, like charcoal, that got trapped in those layers during the quake. By carbon dating that material, they can build a super precise timeline of these huge catastrophic events, going back hundreds, even thousands of years. It's a story written in dirt.
So, all of this digging, all this detective work, it's all pointed to one specific and frankly very worrying area in the Himalayas. It's a spot that's been ominously quiet, and that quiet has scientists really concerned. They call it the Central Seismic Gap.
So what is this gap? Well, it's a huge stretch of the Himalayas, about 650 kilometers long, that hasn't had a major earthquake in hundreds of years. Now that might sound like a good thing, right? But it's not. It's actually the opposite. Think of it like a giant rubber band. It's just being stretched and stretched and stretched, storing up centuries of energy. And eventually, that rubber band is going to snap.
And here's the thing. This quiet zone, it has an incredibly violent history. The evidence from those trenches we talked about shows it has unleashed a whole series of unbelievably powerful earthquakes in the past. We're talking at least 3 major events, including an absolute monster of a quake back in the 15th century that ripped apart almost 500 kilometers of the fault line. Just let that number sink in for a second. Magnitude 8.7. Now, to really understand what that means, you have to remember that the earthquake scale isn't linear, it's logarithmic. So that medieval superquake, it released nearly 30 times more energy than the devastating 2015 Nepal earthquake. This region has seen that kind of power before, and the scary part is the seismic gap is now storing up enough energy for a repeat performance.
So, with all that energy just waiting to be released, you have to ask the question, right? What would happen if a quake like that were to hit today? Well, researchers have run the models. They've looked at the current population data and created scenarios. And even for a magnitude 8.1 quake, which, remember, is less powerful than that medieval superquake we just talked about, the numbers are just staggering. We could be looking at up to 150,000 fatalities, 300,000 injured, and around 3,000 settlements directly affected. It's almost impossible to wrap your head around.
And the thing is, the damage wouldn't just be up in the mountains, not even close. Look at this map. It shows how the impact would spread. Those seismic waves would just roll out for hundreds of kilometers right across the super densely populated Indo-Gangetic Plain and slam into major cities that are a long way from the actual epicenter.
And that, of course, brings us to Delhi. We're talking about a megacity home to more than 20 million people. And it has this really unique geological problem that could take a distant earthquake and turn it into an absolute catastrophe right there in the city.
Okay, these two maps side by side, they just perfectly illustrate the problem. On the left, you see how thick the soil is across Delhi. See those deep deposits right near the Yamuna River? Now look at the map on the right. This one shows how much that soil amplifies the shaking from an earthquake. It's almost a perfect match, isn't it? The areas with the thickest, softest soil are the exact same places where the shaking is going to be the absolute worst.
So the big takeaway here is that not all of Delhi is going to shake the same. A huge part of the city is built on this deep, soft soil that the river deposited over thousands of years. And when an earthquake hits, that soft ground acts, well, it acts like a bowl of jelly. It just dramatically magnifies the seismic waves that are coming up from the solid bedrock deep below.
And this leads to something incredibly dangerous called resonance. See, that soft, jelly-like soil tends to shake at a low frequency. And the problem is, that's the exact same frequency that a lot of mid-rise buildings, we're talking 3 to 10 stories high, naturally want to sway at. So when the ground's shaking perfectly matches the building's natural sway, boom, the vibrations get amplified, sometimes violently, and that is what can lead to a total collapse.
Okay, so the science is crystal clear. The risk is absolutely enormous. The physics of the situation, they're not going to change. Which brings us to the final and most critical question of all. Are we ready for this? What's being done?
Well, the city has started taking some important first steps. The Delhi Disaster Management Authority's strategy is to focus on what they call lifeline buildings. These are the structures that are absolutely essential to have standing after a disaster so you can coordinate a response. And you can see the first 5 they're retrofitting here. The government secretariat, police headquarters, a major hospital, basically the nerve center for any emergency operation.
And look, these are absolutely crucial, necessary steps. No question. But let's be real. 5 buildings. You put that up against the reality of Delhi, a sprawling city of more than 20 million people, with countless apartment blocks, offices, schools, all built to different standards over the decades, and the sheer scale of the challenge just becomes overwhelming. Is it enough?
So we'll just leave you with this final thought from the research. As the population in this region has just exploded over the last century, the risk from these earthquakes has increased by an order of magnitude. The natural hazard, the geology, that's been there for millennia. But what's changed is us. Human settlement has transformed this natural hazard into the potential for a human catastrophe on a truly historic scale.